introduction. So we have fuel consumption, which is dependent, the Y, on which year the car was manufactured, that is model year, one factor. Number of cylinders, another factor, and the weight of the car, third factor. So there are three factors, X1, X2, X3, which affect your fuel consumption. Now I want to build a model which shows how the equation will look like. So what do? I go to data, go to Megastat, correlation regression, regression. Click on regression and it will ask you what is the X, what is the Y. So which is our X? We have 3X, right? Select all the three of them. We have only one Y. Always remember, there will be only one Y. You will not have multiple Ys. Okay? So once we selected both of them, it is asking, do you want any predictions? No, we are not predicting for future values. We are just leaving it there. No other thing selected. Just press OK. Okay, mine will tell error, but it will come. I'll get the answer, don't worry. Now we have the results for the yeah. So we get the results like this. So you see there is the same way like how we got the simple linear regression, right? There are three parts. The first part which talks about the regression values, then the ANOVA table, then the output for each factor that we have. Okay. Now here we are having an R squared equal to 0.785, right? So does it mean there is a good fit or no? But we also have something called as the adjusted R squared. Now which should I use? I should use R squared or the adjusted one? That's a question. The R squared here is against each of the different factors and we are just taking one best thing. You understand? So which means it's not the combination of the three. It is only one of the best. So you should not look at the R squared. You should look at adjusted value. You understand? So for multiple regression, we will take the adjusted value. So the adjusted value is 0.65. So what does it mean? 65% is explained by the factors. 68% of the change in fuel is because of the three factors. Okay. What about, so the remaining 35% is because of other factors. It could be the road condition, the driving style, the wind blowing up, the rain, or modifications done. So many other factors which are not considered here. You understand? So even though we try to add more variables, we still cannot get the full picture. Why? Because there are other factors. You understand that idea? So that's the reason. So there is only 65% explanation. Look at R. R value is 0.886, right? So what is the correlation? Is 0.88, means positive, strong. There is strong positive relation. Okay. There is a strong. Then coming down, we have more values. N is part. Now, if you look at the second part, that's the ANOVA table, we use it to find whether there is a good fit or not, right? So what is the value here? 0.04. So alpha is 0.05 versus P 0.04. So P is significant. Means the model is a good fit. Because it's less than 0.0. That also. So if the value is more than 0.0. Okay, so here if the value of alpha is more than 0.05, then it is not a good fit. Our equation cannot explain the fuel changes correctly. That's the meaning. Okay. If it is less than 0.05, which is our significance level, then it's a good fit. It can explain how much 65% accurate. You get that? Because your adjusted R squared is about 65% changes are explained. Okay, so let's do the next part. So next part is about the regression output. It talks about the different values or the factors that we did. See, it is automatically taking the intercept is this much, the model year, cylinder, weight. So it's giving us the value, which is x1, x2, x3, right? This is x1, x2, x3. And what are the numbers corresponding to this? This is the M1, M2, M3. So how will my equation look like? My equation y is equal to, I have to take the first one, model year, right? 1.103. What is that? Year. I will put multiply or x1. If you want, I will put x1, then I will write it again. x1 plus 1.99 x2 plus 0.009 x3. You see the intercept is negative, right? Minus. So minus 2237. I will call it at 2237. Okay. Minus 2237. About 36.9. So I call this 37. Okay. So this is our equation. What is the meaning of this? Fuel, that is y, is equal to 1.103 times the model value, model year, plus, oh, 1 minute, plus 1.99 times the number of cylinders, plus 0.009 times the weight, plus constant, which is minus 2237. You understand? This is the idea of the equation. The little more about the regression output. Now, if you look at the standard error, we don't use it now. T value also we are not going to use, but we will use p value. If you look at the p value for all of them, this is 0.21, this is 0.31, this is 0.10. Any of them less than 0.5? No. So the question is any of the factors significant? If they ask you, is any of the factors significant, we must look at the p-value. Okay? In our case, in this case, no, none are significant. Why? The reason is no p-value is less than 0.05. Oops. I think I will copy and put it here down. So it is still it doesn't show. Why is it not showing? The factors are not having a strong impact or effect on the Y, which is fuel consumption. Okay, so that is the meaning. Okay, now what I will do. Oh. Okay, I will just take it and I will just put it in the same place. We will type a little more different questions, so it works better. Now, if I have a car from 2010, or no, let's say 2010, 2016 with 4 cylinders and 2000 weight, what is the expected mileage? So if I have a car from a given year, etc. So how do we do this? Now we have the equation. We are given the values for x1, x2, x3. We have to find out the y. Very simple, right? So we write y is equal to 1.103 times, which year it is? 2016, plus 1.99 times, how many cylinders? 4, plus 0.009 multiplied by 2000 weight minus, remember it is minus, 2237. Okay, so this is our equation. Okay, control C, control V. I will just go to the front and remove the y. It will give me the answer. Up. It's taken as a this thing. Why is it not working? It's in the text format. I will type it again. Equal to 1.103 multiplied by 2016 plus 1.99 multiplied by 4 plus 0.009 multiplied by 2000 minus 2237. So I can expect a mileage of 12.608. Okay. If the year is one more, then how much more mileage can I expect? So if the age is one more, instead of 16, if it becomes 17, how much extra mileage can I expect? So if you increase the year, every year one increase means it is 1.1 times. You understand? Yes. If you increase the number of cylinders, then it is affecting by 1.99 times. The weight, for every unit of weight, it is 0.009 increase. You understand? But no, the coefficient or the m value for the year is 1.103. So it will increase by 1.103 times. Okay, so now let me type down the answer here. So if the year is increased by 1, then the slope of year is 1.103. So for every year increase, the mile will increase by 1.103. So I will just copy the same thing, put it here, change this to 2017 because 1 year increase, right? And if you say it is this much, equal to this value minus this value, 1.103. You understand? So we always take the x1 type of question, okay? So, yeah, for the same car, if I increase the weight by 500 units, what will be the change in miles? Okay, so can I do the question? Yeah. So to answer this, what we will do, we will just take only the weight part. The slope of the weight is 0.009 times the increase is 500. So this is nothing but 500 derb 0.009. You understand? So 0.009 derb 500. Oh, equal to. I forgot what equal to. You will increase by 4.5 kilometers. Okay? 4.5 units will increase in fuel. So now what is the question? Car is a practical, right? Yeah. I have a car that is made in 2017 weight 3400 with mileage, let's say 21. How many cylinders could it have? Okay, so now here mileage is 21. So we will put it like this. 21 equal to, I'm just writing it down, then we will solve it. 21 equal to 1.103 multiplied by 2017, because 2017 model, plus 1.99x, because we don't know the cylinder, right? So I will call it x or c. We don't know the cylinder. We have to find out what it is. Plus 0.009, how many weight? 3400 minus 2237. This is our equation. Now I must keep 1.99c one side, all others on the other side. You understand? I put all others on the other side. So I will put it like this, equal to, I will open a bracket. I am putting everything to the other side, okay? 21 minus 1.13 into 217 on the other side, okay? Minus 1, yes, 1.103 multiply 2017 minus 0.009 multiply 3400 plus, because when minus 2237 go that side, it becomes plus 2237 divide by, because only C, no, then 1.99 divide by 1.99. So if you put the enter value here, I get 1.33. So I cannot have 0.33. So it may have 2 cylinders. Yes, round up. No down, no down.